Welcome to WXTV, your online source for weatherization training. This is part 2 of our 2-part series on boiler system safety and efficiency. Let's check back in with Mike and see how he's doing on that clean test and tune.
Okay, at this point what we want to do is determine whether or not the proper amount of fuel is being supplied to this boiler. The way we're going to do that, since this is a natural gas system, is we're going to clock the gas meter. We're at an elevation of 5,000 feet here, so we have to derate the input into this boiler 4% for every 1,000 feet we are above sea level. We're at 5,000 feet above sea level, so we have to derate this boiler by 20%. This is an 80,000 BTU boiler. We want to, at 5,000 feet elevation, we should be seeing 64,000 BTUs of fuel being supplied to this appliance. If more fuel is being supplied to the appliance, then there's a good chance that our orifices are too big, or maybe our gas pressure is too high. And what occurs then is we start creating carbon monoxide. We have a bad burn. We'll go ahead and get this appliance to fire, and then we'll go out and look at the gas meter and clock it. Try to match it with my watch here. Okay, so I'm going to clock how many cubic feet of gas go through this meter. Started right here. The longer my measurement is, the more accurate I usually am. If I take real short measurements, my accuracy goes down. Okay, I had 1 cubic feet of gas go through this thing in 50 seconds. And then I do the math. In our area, the BTU content of our fuel per cubic foot is about 860 BTUs per cubic foot. As a general rule of thumb, most people use 1,000. In order to get the exact amount, you have to look at the power bill, and there's a little multiplier that tells you how to get it there. And we had 1 cubic feet go through the meter in 50 seconds. That comes out to 61,920. We'll just call it 62,000 BTUs per hour. Based on our math for our altitude, we should be right around 64,000 BTUs per hour of input. We calculated 62,000 BTUs. We're a little under, which is great. So we're putting in the right amount of fuel. We're a little bit under, but that's okay. Better than too much. Indications so far tell me we're going to have a pretty good burn on this appliance. Okay, at this time we're going to check combustion efficiency of the boiler. Really what we're looking for is carbon monoxide. We're looking to see if this thing has a good burn, if it's getting the right amount of fuel, right amount of oxygen. This is a cast iron boiler. We don't want this boiler to run too efficient. It's not designed for condensing. If we have a supply run that goes out and it has lots and lots of baseboard on it, it may pull too much heat out of the water, and so when that water comes back to the boiler, it's fairly cool, and that makes the boiler run more efficient, which may be too efficient. It would start creating condensation in the heat exchanger, which is not a good thing. And I'm just jumpering the end switch to get this thing to start. This has a draft hood. It's on the back of this boiler. It's fairly difficult to get to. I have to take this probe and get it up inside the draft hood as close to the top of the heat exchanger as I can, so that I don't get a bunch of excess air. We can see our CO. It's climbing a little bit. We'll see what it does as the thing stabilizes. We want to be under 100 parts per million. At 100 parts per million, to get it down to 25, we got to do a little work usually. Typically it's a gas pressure adjustment, possibly an orifice adjustment. Above 100, we have to get, it's critical that we get it below 100, but usually we can get it around 25. And this one, it looks like it's actually going to just be running in the 20s anyhow. So that's a pretty good sign. So it looks like we have a good level of carbon monoxide. We have a good burn, plenty of oxygen, proper amount of fuel. We look at our efficiency, we're running 85.8. This thing's been running a little while now, and but as it heats up, the efficiency does start to drop. So it looks like it's going to end up hitting in that 83-84% efficient area. Let's take a look at our CO one more time. Let's see, we're at 15 parts per million CO, so that's pretty good. So we have a good burn. Take a look at our draft again, just to see where we are on draft. We're looking at inches of water column, little different number than pascals. We have minus 0.01 inches of water column of draft. So we do have some draft. So we're looking at the flame here on this boiler, and we do have a really nice blue tipped flame, nice cone shaped, which is what we want. And we do have a little bit of these little red tipping on the end, and that's not uncommon. The main thing we're looking at is the main mantle of the cone and the inner mantle of the cone, and those are nice and crisp. Okay, on this boiler, it's pretty easy to take the door off, so I'm going to take the door off so we can look at things a little closer, and even the lid. There's a couple things we want to take a look at. We just took a look at the flames. This right here is the aquastat, and what it does is it has a probe that goes into the heat exchanger, and it measures the temperature of the water inside the boiler. So the boiler cycles on and off, heats the water up, lets it cool down, and then just recycles over and over. And it does that with the aquastat. If we take a look inside the aquastat, there is a dial. Right here's the dial, and this dial turns, and it's set for right at about 180 degrees, and that's where we want to have it set for this heating system. So here's the aquastat. It also has the transformer that provides the 24 volts to run the gas valve and the ignition control, and then also a relay that turns the pump on when we get a call for heat. So this is part of the brains of this thing, and then this is the part that controls the ignition and the power to the gas valve. And then over here we have, this is called a tridicator gauge. Right now the boiler temperature is a little over 180 degrees, and what we want to watch and see is what temperature does the flame shut off. Okay, and that is supposed to match this. Now there's always a little bit of a difference between the two, but we just want to make sure we're not too high on this. We really want the boiler shut off around 180, and if it shuts off a lot higher, we can adjust this over here and get it to shut off at a lower temp. The other thing we want to look at on here is the pressure, and right now we're running at about 16 psi, but we want to be in that 12 to 20 psi range on the pressure. If it goes higher, we just shut off little under 190 degrees, our gas shut off. Now what will happen is we're going to deliver this heated water out to the baseboards. They're going to dump the heat. The temperature of the water is going to come back. It'll be cooler, and eventually this will drop back down, probably around 160, 150, somewhere in that area, and then the flames will come back on. During this whole process, as long as there's a call for heat, the pump continues to run, and we just cycle on and off the gas. Back to that pressure, if we get close to 30, we have a relief valve back here. This valve right here, this is a 30 psi relief valve. When the pressure gets above 30 or right at 30, this starts to relieve water out of the system to eliminate pressure so that we don't create a high pressure boiler here. Okay, one of the things we can do on a clean test and tune for a boiler is we can pull the burners and clean the burners, and cleaning up this area. This combustion air comes in here. The primary air mixes with the gas that's coming out of these orifices, and you can see all this dirt, this lint, because it's in a laundry room, it's critical that, and here's a bunch, it's critical that doesn't go in with the burners, with the gas into the burners. Those little red things that we were seeing on the burn, there's really good possibility it's little pieces of this that are going through there, and then they heat up, and that's that little red coloring that you see way on the tips of the flames periodically. So we would clean this all up. We pull the burners, we clean the burners, blow them out with compressed air, blow them, vacuum them. Another thing we want to do, you're not necessarily going to see cracked heat exchangers like on a furnace, because if you have a cracked heat exchanger, water comes out of it and you'd have water on the floor. But what we do want to look for is a plugged heat exchanger. And we can take our mirror here, and we can take our flashlight, and we can look up into the heat exchanger, and we can see whether or not the openings, if there's carbon buildup or dirt or dust in that area. And if there is, then we need to clean that out. To clean that out, you have to use a brush. And a lot of times you'll move up to the top of the boiler. You'll pull out the bottom burners, and then you'll have to go to the top of the boiler. This is part of our flue gas collector right here. And what you do is you remove this top piece, and then you can look down into the heat exchanger. Okay, here's the heat exchanger down here. You can remove this top piece, look down into the heat exchanger, see the openings where the flue gases come up through. If that is dirty and sooted, then you use a brush and you brush through there and clean that out so that the flue gases can rise up through the heat exchanger nice and easy. Okay, as a little wrap up on this heating system, some things to point out. Number one is the first thing that needs to occur on this system is the proper amount of combustion air needs to be added. We saw earlier how when we put this system in worst case CAS, combustion air zone, when the dryer's running, the bathroom fan's running, how we backdraft. And that is because we don't have enough combustion air in here. So that's most important. Also on this system, cleaning the burners, pulling the burners and cleaning the burners would be something that needs to occur. And then also to add a little bit of efficiency to this system during times when it's shut down and the pump's still running but the flames aren't running, is replacing this vent damper. There's some efficiency that can be gained. This thing's locked in the open position. You saw earlier how at 190 degrees the flame shut off, but the pump's still running. We still have a call for heat. Well, during those periods when that flame's off and we still have a call for heat, this shuts off the flow of any heat from rising up through here. So this would shut off. It keeps that heat inside the boiler so that it can be delivered to the house. With this locked open all the time, that heat rises up through here. So there is, on this heating system, we can gain some efficiency. We can solve some safety issues, and but overall, this is a pretty good running system. We don't have a carbon monoxide issue. The amount of gas and air mixture when the doors are all open are just fine. So those are the things that need to occur on this heating system to get it into a little better shape than what it is.
Well, that's it for another episode of WXTV. Looks like in this system we found some fairly common problems. While there was a clean burn, under less than ideal conditions we found a bit of backdrafting. Looks like the prescription here is to add combustion air. And stay tuned for part 3 of this series, where Mike takes us through the external components of boiler systems. And thanks for watching. WXTV, your online source for weatherization information, techniques, and expert advice.